Hello and welcome. So consider the hyperbola that contains the following: vertices at 0, -1, and 6, -1, and a covertice at 3, -6. Write the equation. First off, you got to figure out which direction hyperbola you have. What's the orientation for this thing? Vertical or horizontal? Well, think about your points here, right? You have vertices at 0, -1, and 6, -1. Between these two, what's changing? It's the x values, right? That means that this has to be a horizontal oriented hyperbola, right? Because if you have 0, -1, right, you have something like that, and then 6, -1 will be something like that, right? It's the x's that are changing, the y's are staying the same, they're staying constant, which means that it has to be horizontal, which means furthermore, let me stop saying which means. Furthermore, the equation for this hyperbola is going to be your x minus h squared over a squared minus your y minus k squared over b squared equals 1. This is your horizontal hyperbola equation because your x term is positive. The term with the x is positive. Okay, if you wanted a vertical hyperbola, all you need to change is that you would just make the y squared minus k over b squared the positive term, and then your x minus h squared over a squared would be the negative term. Okay, that's the only difference between a vertical and horizontal hyperbola. Alright, so we'll be using our horizontal equation because we have a horizontal hyperbola. Right, so let's start finding some information here. First off, we got to find our center. Right, in order to write any hyperbola equation, you got to know three things. You got to know your center, got to know your a value, and your b value. Remember, a value is the distance from your center to a vertex. B value is your distance from the center to a covertex. Right, so we already know one of our covertices, so this is actually going to become really, really fast for us. So first off, center. Alright, we know that the center has to be smack dab in the middle of our two vertices. So if we have one vertex at 0, the other one's going to be at 6, what's the halfway point between them? Half of 6, which is 3. That means that 3, -1 will be our center. Because the y value isn't changing between any of these 3 points, so it's going to be -1 for that one. And then it's just the x value you got to find the middle of, right? And that's it. So then you have that. Now you remember your center is always h, k. So that means that if we have 3, -1, we already know that our h is 3, our k is -1, and we just plug that right in, right? So if our h is 3, so then we have x minus 3. And if our k is -1, we have y minus -1. Well, what's subtracting a negative? Positive, right? Addition. And there you go. That's literally the halfway point. Okay, now we know our two vertices are at 0, -1, as well as 6, -1. Okay, so if we look at that, I'd say, all right, well, we know the distance from our center to one of our vertices is going to be our a. Well, how do we go from 0 to 3, right? What's the distance between those two? 3. That is your a value. We automatically know that a equals 3 because that's the distance from center to a vertex, right? So if you square that, bam! Then we get 3 squared, which is 9. That is your a squared. Plug it into your equation. Okay? Now you have 3 of the 4 pieces of information. Last, most certainly not least, we're told we have a covertex, specifically at 3, -6. So, I mean, technically it would be this direction, right? 3, -6. That way. Okay? And that will be your distance b. So if our center, which we said was at 3, -1. Okay, 3, -1. Then we'd say, all right, well, what's the distance to go from a -1 to a -6? That's 5, right? Which means that b must equal 5. So b equals 5. So if we square both sides, we get b squared equals 25. Plug that right into your equation, so we get 25 there, and that's it. You've now found everything you need to. Everything is simplified, exact. There's nothing more you can do here. And you're done. Thanks for watching.